Hello, everyone. Good afternoon in Europe, good evening somewhere else, or even good morning in the United States. Welcome back to a new session of our Thursdays in the Metaverse talks of the Metaverse UA chair. I'm glad that I can make it this time. I was absent the previous one, but I'm fortunate to being able to moderate this talk with Brittan Heller, that is joining us from the other side of the ocean, of the Atlantic Ocean. Brittan introduced herself as a lawyer working on the intersection of law, technology, and human rights. And she specializes in AI and XR spatial computing. She's a teaching fellow in the LLM program in Law, Science, and Technology in Stanford University. In the past, she has dedicated her career to bring civil rights into a digital environment. And for instance, she established the Anti-Defamation League Center for Technology and Society. She also served in the criminal division of the US Department of Justice. She was a postdoctoral fellow at the Stanford Law School, where I was impressed. I have to say, I have already talked with Brittan about this, that she worked in Kabul and established a law school at the American University of Afghanistan. So as you can see, a background that is not absolutely related with our topic today about XR technologies and the metaverse. However, in this field, before I give her the floor, I highly recommend you, our audience, to revise some of the articles that she has in SSRN, such as Human Rights and Immersive Technology, or Revisiting Code as Law, Regulation, and Extended Reality. Today, Brittan is gonna talk with us about the embodied web in general. And I thank you, Brittan, for joining this activity of our Metaverse UA chair. And I will give you, as mentioned before, the floor for around half an hour, 40 minutes. And then we will have a discussion with our audience that can participate in the chat, and we will make the questions for you. Brittan, you have the floor. Thanks a lot. Thanks again for participating in this second Thursday in the Metaverse talk.
Thank you very much for having me. I really like working in extended reality because it's the closest thing to magic I've ever experienced. And I find it inherently optimistic when I talk about it. You see, I get a big grin on my face. It's because of that I tend to focus on what the internet is going to look like in the future, what role XR has to play in this, and how we are going to keep everything safe and representative and secure. So I'd like to introduce you to what I call the embodied web. And I'll start with a story. Pretend Aurelio and I are in a race car game. And Aurelio, what car do you choose?
What car?
What car do you choose?
Can I choose a Tesla?
He's driving a Tesla.
No, I'm not. I would like to, but I don't.
So in the race car game, he's driving a Tesla. Lucky for him, I'm driving a Volkswagen van, so he beats me in the race. But Aurelio really likes this car, and so when he sees the Tesla, his eyes get really big and his pupils dilate. His skin gets a little more moist, and his heartbeat starts to race a little bit because he really likes this car. Later on, when he goes back into his email, he starts getting targeted advertisements about why now is a great time to get new auto insurance. Later on, when he goes into a sports bar in VR, someone who looks a little bit like a person he finds super sexy asks him, "What kind of car do you drive?" Finally, the next time we go into the race, Aurelio sees the Tesla drive by, driven by someone who looks more than a little bit like him. Now, this seems like science fiction, but all of the building blocks for this type of engagement with personal information and biometric information are already built into XR today. In the example, information from Aurelio's pupil tracking gave the program highly personal information about things like his sexual preferences, his sort of his consumer preferences, and it can also lead to information about your health, your truthfulness, and things that your doctor doesn't even know about you yet. Unfortunately, this is not science fiction. In 2023, there was a study done at University of California, Berkeley, and they used telemetry, so the head and hand motion from Beat Saber. It was a publicly available data set for about 1,000 subjects. They then used machine learning models to guess 40 personal attributes of people, ranging from their age to their gender to their substance use status to their disability status. The study says we conducted a large-scale survey of VR users with dozens of questions ranging from background to demographics to behavioral patterns and health information. We then obtained VR motion samples of each saber from each user playing the game Beat Saber and attempted to infer their survey response by using just their head and hand motion patterns. Using simple machine learning models, over 40 personal attributes could be accurately and consistently inferred from VR motion data alone. Telemetry is very different than pupillometry because you can get much more intimate information from your pupils, but now you don't even have to. It can be the way you tilt your head and point. The move to what I call the embodied web is going to open new frontiers for privacy law and digital governance based on the way that different hardware and data flows work. So we're going to go through a couple points today to delve into what that might actually mean in practice. Number one, your digital exhaust when you're in spatial computing contains more personal information than you would think. This is because spatial computing is different than flat screen traditional computing in one very, very important way. Information from your body and your environment is needed to calibrate spatial computing devices. In other words, you cannot opt out of this data collection. And this is one large distinguishing factor from your laptop or your phone. The traditional web has three different vectors that I like to say come into play when you're looking at methods of governance like content moderation. So the internet uses user content, user conduct, and user behavior. I put conduct and behavior as separate because one I think is individual action, and the other are kind of more collective action. So your engagement with groups. Location-based data was a later addition to the type of data that you provide on the web, based on IP addresses, MAC addresses, all of that. Location-based data is built into XR environments from the onset because of the need to orient the user in physical space. It's needed for user safety, and it's also needed for any of your programming to work. What is also different is the way that the computers are built. So the spatial web adds sensory and movement-based data. And while you see that in certain types of other computing applications, in XR, this needs to be highly accurate. And with it, it brings intimate behavioral and inferential data. As far as I know, there has been only one death of a person in while they were in XR. And this was a user in Russia who was playing with their Oculus and tripped and fell into a glass table and bled to death. So I think it was earlier on, but you need movement-based data and you need sensory input to make your XR devices work. However, there is little visibility into the data flows of your spatial data. Right now, with the onset of new devices, you should be concerned about the protection of location-based data and bystander privacy. It's been interesting looking at the development of new headsets where to combat, if you look at the Vision Pro and Ray-Ban Stories, to prevent people from being secretly filmed with the Vision Pro, there's an indicator on the front screen when it's shooting video or taking photographs. Meta, these are not my my Meta Ray-Ban Story glasses, but if you haven't seen the Ray-Ban glasses, there's an indicator light right here, and it definitely blinks and is on when it's taking video or recording. Earlier versions of the devices did not have this. The initial feedback with Ray-Ban Stories was that the light was too small, and I'm actually an advisor to Meta for some of their new hardware development, and went back and told them this, this is not sufficient because somebody could take a marker and cover it up. Somebody could take some tape, and then your indicator is gone. And the first thing that someone's going to do is take off their glasses and leave them in a restroom. So you really need to think about this. Part of what I do, and I'm not an academic, is I break people's toys. So the second edition of the Ray-Ban Stories had the indicator light, and it was larger, and it was brighter, and it has a kill switch in it. So if don't do this if you buy these very expensive glasses, but if you try to block it out in any way or mess with it, it disables the entire device. Apple also does not allow third-party Vision Pro apps to access the camera to capture photos and videos. And the point of this is to prevent third-party apps from running facial recognition algorithms on people while you're looking at them. To compare Apple and Meta again, I think it was maybe about a month ago now, maybe 6 weeks ago, but when the Orion headset was released, there was a set of student developers at Harvard University. It took them about a week. That's what they did. They developed third-party software running facial recognition apps. So when people walked around, they were able to identify people in their view and get information about them. They were thinking about it more as a version of LinkedIn that in 3D. Some people were saying, "Oh, this could be really valuable. I would really like this." Meta did not agree. Meta shut the project down right away and told the students that they were in violation of the terms of service by doing so. It's really interesting to me because when I've been at conferences, I was at a conference in September, and people were trying to brainstorm new apps for mixed reality glasses. That was the first thing that came up. People were so excited about that possibility to have it be a memory aid and sort of replace business cards at a conference in that way. The Apple Vision Pro is reliant on third-party app developers. That's been one of the criticisms of their spatial computing universe, that there's not enough content because there's not enough people who can build for it yet. When you look at the terms of service, though, I would encourage you to pay close attention to some of the phrasing that is used between Meta and Apple and Vario and other developers. There's a difference between eye tracking, which is what you're looking at in a dynamic form, between gaze vectors and gaze tracking, which is what you're looking at more generally, and pupil tracking, which is your reaction to stimuli. Pay attention because these things are different because they incorporate different types of personal information in the data flow. The Vision Pro tracks your eyes so that you can select things with your gaze in the same way that you move your mouse on your computer. But Apple doesn't share where the users look with the apps, the websites, or even with itself. Instead, it only reports what you've selected with your gaze after you tap your fingers together. That's what I'm doing for you, which is the equivalent of a mouse click. Even given that built-in protection, the responsibility seems to be put on developers themselves for privacy protections. There's a website that Vision Pro puts out for its developers, and Apple warns the users it is your responsibility to protect any data your app collects and to use it in responsible and privacy-preserving ways. It's good to set that out there, but it's another thing to have it be enforceable or to give developers tools to use this or to give kind of more advice about how this fits in with general governance schemes. There's still not a lot of visibility around this. Apple has very, very little visibility into what is happening with data after it leaves the device. Because this data can't be entirely eliminated from most applications, one of the best things that researchers have suggested has been to develop a privacy-preserving tool for VR motion data. That would be a great value add and would mean that I wouldn't be able to give talks like this anymore. But so all of that together means that your digital exhaust in spatial computing contains more than you think, and it's not as secure as you might assume. Number two, existing internet-based systems are not designed to accommodate this type of information. I'm going to give you an example of Lego Universe. Aurelio, do you know what Lego Universe is?
I know what Lego is.
Mm-hmm.
My first kid is a fanatic of Legos, but a Lego universe, I guess it refers to it, right?
Actually, Lego Universe was an early, like greatly anticipated, massive multiplayer online game. It was supposed to be like Roblox or like Minecraft, but it ended up being shuttered. The experience looked great, and this was about 12 years ago. People really wanted to do this, and the company that when Lego planned the experience, they planned to give users the ability to build their own environments. But given how utterly trusted the Lego brand was by parents, the company also committed to doing content moderation beforehand, so to whitelist content before it went in. My friends who are experts in content moderation tell me that there's a kind of salty term, if you don't mind, and it's called time to penis, which means the interval between someone entering a virtual world and adult content generated by users appearing in that world. In this case, it was not very long. Lego needed, amongst other things, to prevent its users from publishing environments with adult content, but they found that they couldn't stop it. There was actually too much with mostly young boys putting little penises made out of Legos everywhere. So the company could not find an automated, scalable, and economical way from preventing its users from creating adult content. It became a widespread problem, and this was a major factor in killing the project. When you look at how content moderation works in traditional social media, you look at three things. You look to actors, behaviors, and content. For example, a person might analyze a user's posted content on a social media platform to determine if it's hate speech or self-harm related content or pornography. Separately, a content moderation system may need to analyze a user's conduct to determine if they're sending out harassing messages or spam or abusing a platform reporting system by constantly making false reports. Content moderation in spatial computing, when we have an embodied web, is going to look different because it has to consider conduct and content, but it also must consider the environment in which the conduct or the content occurs. So in social XR, we have a content layer, which is akin to individual 3D experiences. Think about it like software. We have a conduct layer, and this is where your user-to-user interactions and interactivity between users and the environment will be hosted. But you also have to consider the environment itself. So the architecture of digital worlds, along with the digital objects that users build to populate this world. And one of the challenges I also saw, I always saw with Horizon was you couldn't really fill it with stuff. Nobody wants to go to a virtual living room without a couch, you know. It's better now, but when originally it was just people walking around, that was not compelling. Currently, and this is changing rapidly, so but I think at on this day, there are not enough classifiers to do this effectively using artificial intelligence yet. It will rely on computer vision, which is getting better and better all of the time. But you're still seeing really rudimentary forms. And you will also have problems with the hardware itself, where the latency will need to be reduced so that you can have almost real-time reactions, because you don't want your glasses to be used to help someone cross the street if they have vision impairment, if there's enough latency where it would be dangerous for them to do so. Additionally, different forms of spatial computing, we're looking at AR versus VR versus mixed reality, they have different form factors that will expose them to different content moderation and environmental risks. I brought that up a little bit, talking about the latency for mixed reality or augmented reality. But another example is a user could design like an adult entertainment club and put it in a VR space that's primarily aimed for children. Or they could create overlays of hate symbols and put them on real buildings in AR. A real example that I've seen of content moderation failures in VR worlds was there was a sports bar that had a virtual pool table. And so people would go to play pool, and one of the things you could do in the sports bar was buy somebody a drink. When you bought them a drink, it would just kind of plop down where they were, right in front of them where they were. And when people were playing a game and wanted to keep the room private and not have other people join, when a new person would come in, they would all buy that person so many drinks, and then I say buy because it was free, that it would fill up the entire pool table in front of them and that person couldn't play. So it was kind of akin, that's what I think spam looks like in the metaverse. It is actions that are used to impede gameplay and impede the progress of the programming in the same way that spam in email clogs your inbox um, and stops your email from functioning. Spatial computing must look to conduct, content, and environment if content moderation is going to be demanded by law and if it's going to have continued relevance. While computer vision is going to help us identify objects, we need to make sure it has the speed and accuracy needed. And we need to start asking what user-generated content is going to look like in 3D computing, because we need to think about how existing laws will integrate with these systems. And in many legal systems around the world, user-generated content has a very specific legal definition. And I am finding that you cannot take 2D laws and cut and paste them into 3D spaces and expect they're going to work the same way. Right now, we're just starting to see how the law is going to treat body-based data. And when I say body-based data, I'm very intentional about that because biometric data is a legal category. Body-based data is not a legal category. Spatial data is not a legal category. At least in the United States, this distinction is a very important difference. Because privacy law is premised on your personal identifying information and protecting that, protecting your identity. This is much bigger than that because it contains behavioral and inferential data that in certain jurisdictions will be outside of the bounds of privacy law. I think this is much more attenuated and specific in spatial computing, and another major difference between flat screen internet and the 3D web. I talked about the study at the beginning where you could identify 40 personal characteristics about an individual from their telemetry. There's another study done by Stanford in 2022, and they were able to personally identify one person out of a data set of 2,000 with 100 seconds of telemetry data, of motion-based data. Berkeley and Stanford have a rivalry, so Berkeley decided to take it one step farther. They did the same experiment, same intervals, but they expanded the data sets to 55,000 people. Think about like a soccer stadium full of people. You can identify one person from the way they tilt their head and point at a football match. And this is it was as physically identifying as a fingerprint. In Europe, you may have better news. It is very likely that coverage under the GDPR is possible with XR data being included as highly sensitive or sensitive data. But it's uncertain in other jurisdictions like the United States, who tend to fall behind with their conceptions of privacy law. And I consider non-consensual intimate image coverage in the United States. They're still debating a law this week about trying to make what is called revenge porn against the law on the federal level. It took until 2023 to get 48 state out of 50 state coverage. And this is a long known harm. There's celebrity advocacy behind it. There are legal superstars in the United States pushing for this as a criminal violation, to make pornography or to distribute pornography of someone that is taken against their consent. So other jurisdictions are still trying to grapple with what privacy means in a digital age. One realm that you can start to look at to see how spatial data may be treated is some of the new regulations that are coming out around neurotechnology. Lawmakers in Colorado introduced an amendment to the Colorado Privacy Act that would expand the definition of sensitive data to include biological data, and specifically neural data. And it defines biological data as data that provides a characterization of the biological, genetic, biochemical, physiological, or neural properties, compositions, or activities of an individual's body or bodily functions. So new laws that are being proposed in the United States equate biological data with neural data. And neural data can be seen as equivalent to the type of information we have in spatial data flows. So this is a space to watch. It's not completely formed yet, but if I were to look at areas where you could find indicators about how governance is going to look, laws around AI and laws around neural data in particular would be how spatial data may be grappled with, not necessarily privacy law. I think the third major difference between the spatial web and the internet is that you observe the World Wide Web, but you viscerally experience virtual worlds. And if you're coming to this talk, you probably know this very well. You know that this is not social media. So this is different from any type of computing that has come before. For me, the main difference is not just the magic, but the mechanism. Your body and your mind react differently to spatial computing because of the aspects of presence, immersion, and embodiment. And I use Jeremy Bailenson definitions when I talk about this. So presence is what he defines as the illusion of non-mediation. When VR is done right, it feels like magic, meaning there's no gadgets, there's no headset, it's just you and the experience. In other words, VR feels real. Bailenson says that we should think of VR not as a media experience, but closer to an actual experience. And I've done a lot of work with his lab at Stanford, the Virtual Human Interaction Lab. And one of the things we do when we bring people into the lab is we ask them to walk the plank first. And I brought in a bunch of German regulators. They were actually the first ones who proposed the GDPR, and they were a little skeptical about the experience at first, and by the end, they were crawling across the floor. It was so visceral to them. So before talking to them about empathy, before talking to them about education or medical uses, we wanted to demonstrate to the regulators why VR has a long historical success of treating phobias like VR, because it feels real. And that is very, very different than the internet. Immersion is when users feel like they are in an alternative environment, and this is how you set the scene. And it's important because the way you do this is what makes VR feel real. I always say it's like going to a theater and thinking about all the aspects of being in a theater that make it different from watching a movie in your home. You have to think about the different views from different seats and spatially oriented sound that seems to come from different locations and the different lighting when the performance starts. And so XR kind of has this same type of stimulation by using light and sounds and tactile stimuli if you're looking at haptics. And we in the lab, we even used to have smell-o-vision. The company stopped making the cartridges, which is a shame, but we could put people in VR and give them a virtual stick and then have them roast a marshmallow over a campfire. So not only could they see it, not only could they hear the crackling of the fire, they could smell the marshmallow and smell the charcoal. It was fantastic. The most important aspect, I think, is not presence and not emergence, but embodiment. And this is feeling like the form of an avatar or a virtual body is your actual physical body. Mel Slater in Barcelona demonstrated the importance of this by importing the rubber hand illusion into VR. If you're not familiar with it, researchers placed a toy hand in a user's field of vision within VR and then abused the hand. And users found that when they watched this violence or abuse inflicted on the toy hand, they experienced the sensation in their own body as if it was happening to their own real physical hand. Embodiment is also how the magic happens. It's very powerful. And this is why we have beneficial medical applications like helping alleviate phantom limb pain or helping people with therapeutic applications or educational contexts that are designed to engender empathy. But not a lot of people think about the flip side of it, which is how violence and harassment that many people report experiencing in social XR environments can have that same impact on people. It feels real. The characteristics of presence, embodiment, and immersion lead to different psychological and neurological impacts for users. When you experience something in VR, it is written on your, it is processed through your hippocampus. Tom Furness, who invented one of the first VR headsets, says this means it is written on the brain in permanent ink. The pluses are for education and training and accessibility. And this is why we see this being the most powerful computing tool and teaching tool that we've ever developed as a human society. The negatives are equally poignant, though, because an assault in the metaverse feels like an assault just in the metaverse. The UK Public Prosecutor's Office has opened an inquiry as of January into a report of a 16-year-old girl who said she was sexually assaulted in the metaverse. They are actually trying to charge it as sexual abuse. This is very interesting to me as a former prosecutor because normally one of the elements of sexual abuse is touch. And if they are charging this type of a case, they believe that they can win, which means that we have to look at how existing law is going to intersect with extended reality. Will the requirement of touch be sufficient for digital interactions? And if it is, what does that mean? Because of how spatial experiences feel real, online harms transfer from traditional flat screen computing to spatial computing, but the harms manifest in a more visceral way. And so this is why the prosecutor's office said that they opened the inquiry, because to the minor, she said that she was assaulted, and it felt like she was assaulted. There's a history of people who experience this or who have reported the same type of phenomenon. In 2016, a journalist writing under the pseudonym of Jordan Bellemere wrote about how groping in an archery game felt like a real violation. And the platform responded quickly by creating a personal space bubble. And that's how you started to see that development in VR programming. That's what really prompted it. Nina Jane Patel of the UK wrote about a sexual assault in the metaverse in 2022. And that's how you started seeing some of the the platforms building even more safety features, like the ability to port out or to kind of standardize their reporting mechanisms. The fourth point about the embodied web is that AI and virtual worlds are linked and will continue to grow closer. I think it's very clear now that emerging tech works in ecosystems, or what I like to call constellations. And I think if you're looking at this from a regulatory perspective, if you focus on one part of the constellation in lieu of all the others, you miss the bigger picture about how all of these devices will interact. It's also very clear, especially to people in this sector, that algorithms are the fuel of virtual worlds. AI is playing an increasing role in even populating these worlds. Multimodal inputs from generative AI now allow you to create 3D objects or even environments without a sophisticated understanding of coding. This may help with governance to some extent. You've created more tools for content moderators. There may be more data sets for computer vision, but it's uncertain if creating artificial data sets will actually pollute the AI. That's been some of the initial research coming out, that artificial data sets don't actually help in the way that we hope they would. AI is integral to how we process body-based data. Meta has lots of capabilities with their codec avatars, which are photorealistic. One of the capabilities is called audio to photoreal, where the avatars mirror your facial expressions and correspond with bodily gestures based on your audio. And so this is a little different than some of the algorithms that you've seen where you're creating a deepfake video or embodying a celebrity using generative AI. These are full-bodied photorealistic avatars that are naturally gesture-driven by the author's voice. The body motion is synthesized using a diffusion model based on the audio or the text, and the facial motion is constructed based on the audio input as well. So if I were to say, "Whoa," it would, based on that track, you could see me having my hands thrown up, you could see my face reacting in a way, and that's all created by algorithms. It will impact depictions of my mouth, my face, and my hands without the use of motion tracking. So this is one of the newer frontiers, and based off of behavioral and inferential data as well. The way that I describe what the new internet is going to look like is I use the term embodied web, because I hope after the lecture it's clear that there will be these reciprocal relationships between information from our bodies that go into computing devices and then information from the computing devices that come back to us. So it's this reciprocal relationship. And that's why the next version of the internet is going to be embodied. It's going to have sensory information, which is the absolute newest type of input. This will open new frontiers for privacy law and digital governance based on the different affordances of the hardware and the content of the new data flows. That's all I've got to say, and I'm really happy to open it up to discussions and questions at this point.
Well, thank you very much, Professor Heller, for such an insightful and thought-provoking seminar. Of course, we remind everyone, all the attendees, that they are still in time to formulate their questions in the chat. And we already have one from Emmy Hein, which said, what will be necessary for this body-based data to be covered under the GDPR's definition of sensitive data, either a reinterpretation or a rewrite of the law?
I'm trying to scroll through to look for the question so I can read it.
Yes, of course.
There we go. Okay. I don't think you need a rewrite of the GDPR. There are many people who believe that, I think people coming from advocacy organizations like Access Now, that Article 1 of the GDPR means that this data is covered. It would be more useful to have judicial opinions that solidify that for people, because then we're seeing challenges in distributing the hardware based on the lack of clarity around international legal regimes. No company is going to want to distribute their hardware or release their programming in a situation where they feel like they can be held liable for it based on the lack of clarity in the law. So I think here, not reinterpretation, but interpretation will be the key. In other jurisdictions, it may take a rewrite of the law. When you look at the United States, the closest thing we have to the GDPR is the CCPR, so California's version. This is Stella, apologies to everyone. California's version of the GDPR. It was based very closely on that. And so I think that is where reinterpretation may be necessary to have it sort of gel with other national laws in the United States, because you have a difference between state level and federal level laws.
Yeah, thank you very much. Then we have a next question from Giovanni Sorrentino, who points out, if you were a legislator, what would be the first law that you would enact regarding the metaverse?
Well, that's a really good question. So in some of my other, I didn't talk about it here, but in one of my papers, I invented a term, which is a very thrilling thing for a baby professor, called biometric psychography. And by that, it's basically the example that I opened with at the beginning with the race car. I do not think that it is defensible to allow a company to make targeted advertising based on your involuntary responses to data. I think you cannot meaningfully consent that away. Just based off of other type of laws we have around what we can and cannot do with our bodies, it just doesn't seem like you can consent to give away information that your doctor may not know about you yet. How can you write away that medical information? So that would be where I would start, actually. I think it would have a lot of repercussions, because many of the major VR hardware providers have now invested billions of dollars into hardware development and have not seen that investment come back yet. So they are looking at ways to monetize their investment, and one of these ways is advertising. I have another paper called In VR, Nobody Knows You're an Ad. And it talks about what advertising actually looks like in spatial computing. The earliest experiments, people thought it would look like a billboard. So in Blast and VR, they announced they were going to have ads, and they were just billboards in the background. And within 5 days, users revolted to the extent that the company canceled the project. Meta is now talking about reinserting ads in VR, starting with a billboard-based model. But that's not what it actually looks like. Advertising in VR looks like it pulls from entertainment and sports and gaming. It's experiential, so you pay for the privilege of being advertised to, and you seek it out. I tell people it's like going into a Jurassic Park experience and feeding the dinosaur. That's an ad for the Jurassic Park movie enterprise. So it's not the same as a billboard, and it's not the same as a banner ad. So again, 2D laws do not translate into evolved forms of computing experiences. That's what I would do, because it feels like a violation of user trust. And I always say that biometric psychography is like Cambridge Analytica on steroids. Once that information is out there, we can't get it back. So that's where I'd start.
Well, I think we have no more questions, so then it's time to close up the webinar. Again, Professor Heller, thank you so much for your participation and for your willingness to be here today. We know you have a busy schedule, so we once again thank you for making some time for us. And also thank you to all the attendees for connecting and for posing such interesting questions. We hope to see you in the next webinar that we will be hosting on the 12th of December on NFTs by Professor Larry Di Matteo. And of course, we will also upload the recording of this webinar to the web of the church, so you will have time to revisit this experience. So thank you so much, and goodbye to everyone.